Hello, this is Kyle Chapman. This is the first in a series of videos in which we'll talk about planning a Python application. So far, you've probably, hopefully, watched the Getting Started videos. Ideally, you've also read the relevant chapters of the course textbook, which are listed on DC Connect, and at least attempted to write your first program for the course. In this video, we'll talk more about programs and programming, and then we'll talk about algorithms. In one of the Getting Started videos, we discussed the meaning of the word program, and the video said that one textbook definition for a computer program is data and instructions used to operate a computer. We also talked about what a programming language is. A programming language is how we write something that both a computer and a person are able to understand and use. Next, let's talk about what an algorithm is, and we'll start off with an example. Let's suppose you're on site at Durham College, which I know could be pretty unusual right now, but let's suppose you're on campus and it's time for lunch. So you have a goal or a result that you want to achieve, which is to get some lunch. There's a whole lot of different ways that you can actually satisfy that result. You could go home and make a sandwich. Now, that's actually a very high level instruction. That would break down into a lot of different steps. You might have to move from where you are to the bus stop or to the parking lot, and then find your way and travel to your home using whatever technique you would use, to say nothing of how you make a sandwich. A second option could be you go to the cafeteria and buy a slice of pizza. That satisfies the goal, but it's an entirely different way of satisfying the goal. And then another option might be to go off campus to a restaurant and buy whatever the special is. Again, you're satisfying the goal, but you're taking a completely different approach to doing it. In a nutshell, an algorithm is the step-by-step instructions of how you're actually going to achieve your result. And there's pretty well always more than one way of completing a given task. So how is an algorithm different than a program? Well, basically an algorithm is descriptive. It's not written in a programming language. It can be written in something that programmers usually call pseudocode, which essentially is just English that is written in kind of a code-like fashion. Sometimes an algorithm might be represented graphically with a flowchart or another type of illustration. Any given program might be made up of a number of algorithms that have been implemented by translating them from whatever form they're in into the actual programming language. That process of switching from your English-like algorithm to actual program code is what's known as coding. Now, if there's one thing that we really want you to understand out of this entire course, and that's probably more important than anything else, that you need to understand before you sit down and you start coding your program or even designing the algorithm, you really have to understand the problem. And one technique or one sort of approach to understanding the problem that we suggest is starting by thinking about the desired result and really understanding what it is that you're trying to achieve. So let's call that result the output. The output could be output to a screen, but it might also not be that obvious and straightforward. It could be the result of some computation or some action. Maybe that result is that you've successfully eaten lunch. The next thing you typically think about is the data that is going to be used, and how are we going to get it? And that's the part that we're going to call input. This is sort of thinking about our current situation when the program starts. We know what kind of result we want, but where are we now? Once you understand those two things, then what you get into is how to get from that starting position to the result. What is the procedure that we need to go from where we are to where we want to be? And these planning steps are clearly a little bit out of sequence considering how a program will actually execute, but it's very helpful to plan things in this order. Otherwise, you're designing a procedure that maybe doesn't get to where you need to go, or it just can't start properly. So let's break from definitions, and I shall tell you a story. A programmer was home one fine day, and their mom said to them, "Honey, please go to the market and buy 1 carton of milk, and if they have eggs, buy a dozen." So the programmer goes off to the market, and when they return, they are carrying 12 cartons of milk. Their mom asks, "Why the heck did you buy 12 cartons of milk?" And the programmer replies, "Because they had eggs." So that probably got a couple of groans, and here's the sad part. I have to explain that joke in full. This is mostly to make the point, but partly because the meaning hinges on knowing the mechanics of the English language, and not everyone does. That joke would work differently in other languages. The instructions were, "If they have eggs, buy a dozen," but the subject of the sentence was carton of milk. So the programmer very literally interpreted that since there were eggs, the milk is what they had to purchase a dozen of. Now what I'm attempting to illustrate with that little story is that the computer is an algorithm responding machine. It takes the code that you write very literally. It doesn't fill in any details. It doesn't make any leaps of logic. It doesn't know your intentions other than the fact that it will do exactly what you tell it to do. Human beings don't tend to think that way. Some are close, but even the most logical human beings wouldn't actually go out and buy a dozen cartons of milk. We are more intuition based. That means you can give a human being an instruction and they can sort of fill in some details. and they might be able to interpret things to create the algorithm for what they're going to do. A computer doesn't work that way. So again, we really emphasize that whole planning piece. Here's an example of a very simple algorithm for calculating someone's gross pay. This is basically what you would need to tell a computer to do that task. You need to explicitly tell it to display a message asking the user for how many hours. There has to be some mechanism, some code, to allow the user to type in their number of hours on the keyboard, and then that has to be translated and stored in memory somewhere. Another message might need to be displayed saying, what's your hourly rate? And we go through that whole getting the user to input it and then storing it in memory. And then finally, we have to actually calculate the gross pay by being very explicit about the calculation and then display a message with the results. It has to be pretty detailed when you tell a computer what to do compared to what you might need to tell a human being to do the same sort of task. For a person, you might just sort of say, hey, tell me what the user's gross pay is. And a human being's usually smart enough to figure out what the steps are. You don't need to necessarily spell out every single step. That's just an illustration of the difference between an algorithm responding machine and an intuition-based human. In the Getting Started video where we discussed programming languages, I mentioned that there were a bazillion programming languages. A really important note at this point is that algorithms are really just sets of repeatable instructions. They don't depend on programming languages. You don't need to know how to code to understand algorithms, and you don't need to know what an algorithm is to write code, although it certainly helps. Even though in this course we are using Python, anything you learn about algorithm design and planning as a part of this course is completely portable to other programming languages and even to other parts of your life. So in this video, we dealt with a few definitions, and we mostly talked about what an algorithm is. Some questions you should be able to answer now. What is an algorithm? What is the distinction between a computer program and an algorithm? You shouldn't need to look anything up to answer these questions if you've been following along. After all, there are tons of possible good answers to questions like this.